Hello, it's me. So now we're going to see if we can't fulfill the challenge of doing a non-shape-shifting scramble and non-shape-shifting solve. We went over the basic concepts with the supercube, and this is the archetypic supercube basically. It could be Shepherd's cube, it could be a variety of different types, but let's see what happens with this. So it all starts off with a 180-degree non-shape-shifting scramble. Just turn it around and around and around. Now the thing about these 180 is I actually get the concept. At first I'm thinking, why would you want to do it? And the thing about it is there's a lot of really interesting puzzles that are out there, but not everybody can afford them. So what's interesting is that a lot of the things you get out of some of these more complicated puzzles you can recreate with a normal 3x3. These parity algorithms that we do is what I use for the 3x4x5, the 4x5x6. So you can take a 3x3 and do things to it. Bandage it, restrict it to just 180-degree turns, and have yourself the same kind of a challenge that you would with more expensive cubes. Okay, so there you have it. A nice non-shape-shifted scramble. So what's our approach? Well, the whole key here is perspective. Perspective is the key. So understand that this is the top if you wanted to define it as such, and then you have to be careful what your F is going to be. The F is going to be the one facing you. Now don't orient it like this is a side. You're going to get screwed up. This is actually a side, so this is the top side. So the first step, just like we did with the 3x3 supercube, is to orient our centers. So here's a center here, and I'm going to orient it to where all of the reds are facing each other. Yellow, I need to put this yellow here, so it's facing here. And this is facing here. Green, green, green. Blue, blue, blue. Okay? So, same steps. Next step is we have to put our corners in. You may find when you do this, the corners might accidentally be solved. So what are the corners? Well, bear in mind, this is a corner, this is a corner. These are all corners here. So if we were to try this part first, what I have to do is maybe put the green triangle over here, which is over here. So the first step would be to put this over to here. This is where this corner belongs. So I could move it like here and like here, but then I've messed up my centers. So you remember how we did that with the supercube. I had to move this down to sort of receive this and then move it in. So I have to coordinate it with the center over here. So double turn it and then move this in. So now this is coordinated with the center, and then move it up and then move it back. Okay, so now this is where it needs to be. This corner here too is also where it needs to be because we're looking for the blue, green, and red, and this is in. So these two are in. Now I have to put the other one in here, which is going to be the green, blue, and orange, which is not this one, it's this one. Now this is probably coordinated with the other corner, which is here, and that's got to be the blue corner, which is right over here. So basically, these guys have to turn into here, and everything will be fine. But I can't just move it in. I'm going to mess up the center here. So I got to take this and move it away from this center. So double turn it, turn this down, move it in. So now that we're coordinated, and move it here. And then of course we move it back. Well, in this case we can keep it here. So now you can see we've got all of our corners in. And that's not too hard. Now comes the challenge. So this kind of has a skeletal structure to it, where corner, 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 corner in, center, you're going to find that all around. Now, it's a little difficult to get your orientation, but understand that if this is the top side here, just like this over here, we wanted to swap these two with the algorithm. So if this is the top here, which two are going to be swapped? And the answer is these two. How do I know it's those two? Because when I move this, it's going to be the two edges that are not affected by the turning here. And it's going to be adjacent to the center that's just below this. So what does that mean? Well, looking at this is the center that's just below it. These are the two that are adjacent to that center, but not affected by this turn. So if I do the turn where this is up, this is F, this is R, this is L, basically these two are going to swap. Do I want to swap these two? Not really, because I kind of like where this one is. So let's go ahead and find another one. I don't want to swap these two either. Alright, so here's an up. These two will swap. I want this to come over here. Now bear in mind, this is going to turn 180 degrees and this is going to turn 180 degrees because I'm defining this as F and this is up. Now this is the part that you have to really concentrate on. So we're going to swap these two, but what else is going to be swapped? The other one that's going to be swapped on here is the edges that correlate with the edges here, which is here and here. So that's going to be the other edge that's moved by the top and is adjacent to the center to the right. What the heck does all that mean? Well, so this one is moving here and it's adjacent to the center, which is our right center. So this and this are both going to be swapped. Alright, so basically the end result is when I do this algorithm, these two will swap and these two will swap. It takes a little bit of practice, it takes a little bit of getting into. Now, I don't particularly want to swap this one. I'd rather swap one with a green. I'd rather put a green in here. So I'm going to deconstruct it, take this green and put it here just by rotating like that. So the end result of this is going to be where it needs to be and this is. But bear in mind, these two are going to be rotated 180 degrees. So let's see if we can't apply our algorithm here. Just bear in mind, we deconstructed it to here. So it's 2u, 2r, 2f, 2u, 2f, 2r, 2u, 2f, and let's reconstruct this back. So this is where it needs to be. This is rotated, so don't let that fool you. But you can see this is right and this is right. Now, you're going to make mistakes with this, so just check your work. Make sure our corners didn't come out. It's very easy to lose perspective. Okay, so these two are rotated. If I can, I'd like to keep it held here so I can rotate this back. So ultimately, I want to put a red one here because this will rotate back. I can see there's a red one here, so I can deconstruct it from here. This will put the red one here. This green one will end up over here. Do I care? Well, no, not particularly, because this green one, when I move it here, is going to be into this place, which is where it needs to be. So I'm going to swap these two. Okay, what am I swapping here? Well, when I put this here, I'm actually swapping this green one with this blue one, so I'm going to create parity over here. Do I care about that? Well, sort of, because I just put this one in. So I could deconstruct it even more, but do I really want to get that complicated? Possibly, because if I turn this over here and swap these two, and then turn this over here, then I can swap these two. I'm not going to make it that complicated. So let's just go ahead and do the algorithm and see what happens. 2u, 2r, 2f, 2u, 2f, 2r, 2u, 2f. And as quick as we can, reconstruct it back to where we had it before. So now these two are in, all of these are rotated correct, and it's true, I did swap these two, which is not something I particularly wanted to do, but now I can orient it, say like this, put this one on top, so that these will be the next one to move. So I'm going to do it to where these two will move, and this will rotate. I don't particularly want to rotate this one out, but if I rotate this here, this blue will find a nice home over here. So why don't we do that? Okay, just remember to deconstruct it back when you're done. I just basically did a D move here. 2u, 2r, 2f, 2u, 2f, 2r, 2u, 2f, and then reconstruct this back down over here. Okay, so that's not too shabby. I was able to do that. Now this got rotated out and this got rotated out. So I don't need to change the configuration of this. Now remember, we had a similar situation with this where we had to kind of double turn to see if we can match something on the other side. Can we do something similar here? Well, I see these two are out and this one isn't rotated. They are truly out. So if I go like this, 1, 2, this is now here. 1, 2, this is now here. So I'm going to swap these two. Let's see what happens. 2u, 2r, 2f, 2u, 2f, 2r, 2u, 2f, and now we just swap these back. That put these back and put everything but just a couple ones that are out. So we're getting there. So now we're down probably to the last two moves. The first one is going to put centers out. Let's try to swap these two over here, and let's kind of create a clean parity between these two here. 2U, 2R, 2F, 2U, 2F, 2R, 2U, 2F. So this is where it needs to be. We did create a, quote, clean parity from here to here, so that hopefully will just move back. Now that this is where it needs to be, what I want to do is move this into where it's supposed to go, which is going to be in a yellow, which is over here. So what I have to do to deconstruct it is I'm going to be moving this down here and then this up here. So I have to remember to turn this back and turn this back over here. So 2U, 2R, 2F, 2U, 2F, 2R, 2U, 2F. This turns down over here to reconstruct it. This turns back, and it's done. Okay, so if that was hard to follow, that's because it takes a lot of brain-bending perspectives, but basically you just have to bear in mind the rules of engagement. It is exactly the same thing over here, but that's how you do that. Thanks for watching.